let's start off with adding a line renderer. If you're seeing the pink texture, that means there isn't a material. I have already gone ahead and made a material here. That's just a small arrow, but you can use any material you'd like. Since we're dealing with the 2D environment, we won't really see the Z-axis here. So let's go ahead and change that to 1. And if you want, you can change this to transform.z just so that it doesn't rotate around. And if you stretch this up here, by default, the texture mode is set to stretch. If you want this to tile, just go ahead and click on it and select tile. Okay, now that we have our conveyor belt here, let's go ahead and create a script for our conveyor belt. Alright, let's open it up. And for now, I'm gonna go ahead and remove the boilerplate code, and I'll just show you what the main concept of the conveyor belt looks like. From then on, if you don't need my help, you can carry on and make this conveyor belt on your own. And this is pretty much it. The whole concept of the conveyor belt relies on lerping. We're just lerping from one point to another on the line renderer. You can see as I change this value from 0 to 1, it moves along the conveyor belt. However, we don't really want to manually move the items on a conveyor belt, so let's go ahead and make this automatic. First, I'll change this from lerp value to speed. We will multiply this by time.delta time to make it frame rate independent. But this doesn't really keep track of how far up we are on the segment of the line renderer. As you saw earlier, we were manually shifting it from 0 to 1. Multiplying this by the same number over time.delta time doesn't really get us anywhere. So we need to keep track of how far we are up the line. Let's add a new float here. And instead of multiplying it here, we'll do it here. So our lerp speed will continue increasing based on our speed, and the time.delta time, that value will automatically increase, and as we go on the update, this will eventually reach 1. And I might have made a mistake here. This isn't supposed to be equals, it's supposed to be plus equals. Alright, let's test. I've set the value here to 1, and I've increased the length to 15. Oops, 15. Yep, there we go. It moves up the line automatically. I'm gonna slow it down just so we can see it better. And yep, there it is. This is the core concept of the conveyor belt. Now let's handle turning. If you recall, our lerping value goes from 0 to 1 for every item, regardless of how long the line segment is. We can use that to our advantage to do some checks if an item's lerp value has reached 1 or greater. If there's another point to lerp to, then let's start lerping towards that next point. However, if we've reached the end, then let's just have the item stop there. Alright, let's see what that looks like in code. Alright, so what we're gonna do in code, oh fuck me. Okay, so like I mentioned earlier, if we have reached the end of the line segment, let's check if there's another point to go to. If yes, let's go ahead and reset the lerp value and start lerping to the next point. If not, we've reached the end of the conveyor belt and there's nowhere else to go. Alright. So obviously, let's go ahead and start. If current lerp is greater than or equal to 1. We obviously want to do stuff here. But we need to check, we need to do some refactoring here just to make our life a little bit more simpler. Alright, I've gone ahead and extracted the indexes for the point to lerp towards. This will make it easier for us to check if we've reached the end of the line. Alright, and this is the check to see if we've still have space to go. And if you don't have space to go, we've reached the end of the belt. Okay, so checking our notes from before, we'll have to reset the lerp value. And let's start lerping to the next point. if you have some logic that needs to be done when you've reached the end of the belt, you can do it here. But since I don't have any, I can just remove it. Alright, let's test. Alright, over here in Unity, I've just gone ahead and created another point here, and let's see how it goes. Alright, it's making its way up. And yes, in fact, we do see it turn. Nice. If you'd like to see it in action, just go ahead and enter the debug mode. And you can keep an eye on current lerp and the endpoint. Alright, you can see here, we're lerping all the way to 1, and we've reset back down to 0. Now there's something you've probably noticed while watching it, is that the speed actually changes when it reaches this shorter section. This is because the lerping distance, or distance in units here, is shorter than the distance from here to here. With that logic in mind, if I go ahead and extended the length here, we should expect to see the item move faster on this section compared to this section. And yep, it does in fact move faster on the longer section compared to the shorter one. So how will we combat this? Now there's probably a cleaner way to have done this, but what I just did was divide it by some form of distance. And this is the change needed to fix that. All I've done here is I've created a new distance variable, and I've taken the distance between the endpoints. And I've just factored that into the lerping calculation. This makes it so that larger distances divide this into smaller values, and smaller values get multiplied because any value divided by a value smaller than 1 will get multiplied. And if you don't know what I'm talking about, if you take 5 divided by 0.5, it actually multiplies it by 2. That way, larger distances get divided and smaller distances get multiplied. Pretty cool. Alright, let's head over into Unity and test. It's moving a little slowly, so let's increase the speed. I'm just looking at it, trying to gauge the speed, and yep, it looks like it's moving the same speed as it was on the previous segment. Very nice. And let's see what happens when it reaches the end. Very cool, it just stops there. Now, our final step is to make multiple items move on the conveyor belt, because obviously we want to have more than one item to move. We also don't want them to collide with each other, so it looks a little bit more satisfying, just like Satisfactory or Shapes.io. Before we carry on, let's go ahead and create a class to make all of these variables clump together. And let's make it public for easy access. And since generally we don't want to see this in the inspector, let's go ahead and hide it. Okay, cool. Now, instead of a singular item, we'll have a list of items. These will be all the items that are currently on the conveyor belt. Now we just need to turn this from a single item into a for loop. I'll go ahead and extract all the variables for easy access. And let's fix all of these errors by making sure that they're referencing the correct variable. Okay, done. We have a new field here called items, and I've just gone ahead and duplicated all of the items here. Now let's go ahead and fit all of them into the list. Okay, cool. So let's test. And you can see the items moving along. Now if I go ahead and select each and every single one of them, you'll notice that they're all in the exact same spot. Because right now they don't have collisions. But it's safe to say that all of them are in fact moving on the conveyor belt. Back to the code, we just need to do a little bit more logic to make sure that they don't collide with each other. The simplest way we can tackle this problem is to just check via distance. And instead of giving a hard-coded value here, I'm going to go ahead and turn it into a variable. And if we are less than the item spacing, we don't want to move this object, So let's go ahead and just call continue. This will continue into the next loop, but it doesn't run all of this logic. However, before we go ahead and test this code, you might want to check this if statement a little bit carefully. If I is 0, we will be checking for a 0 minus 1 index, which is -1, and -1 in a list will result in an out of bounds index error. This is obviously not what we want, but the first item in the conveyor belt will always have space to move, so let's go ahead and just check if we're not the first item. There. This ensures that the first item always has space to move and the ones before them always check. Nice. Let's go ahead and test this code. Over here in the conveyor belt settings, I'm going to change the item space to something like 0.5, just to test. And it looks like we're getting an error. This is happening on line 28. Let's double click to check it. And obviously I've made a mistake here. We don't want it to be greater than or equal to 0. We only want it to be greater than 0. Alright, let's test it again. I'm gonna increase the spacing value. And there you have it. There, very nice. Now let's see what happens when they all reach the end of the line. Very nice. They all just stop there and everything looks wonderful. Now you might be getting some errors here at the bottom that says index is out of bounds. And what's happening here is that endpoint is not a valid index in the line renderer position. This is because even though we've set it to 1 here, if we remove the hide in inspector value, you can see it still defaults to 0 here. Now I'm not entirely sure why it does that. The quick fix around this would be to rename it by pressing Ctrl RR. We can change it from endpoint to start point. This means that we no longer need it to be initialized as 1. We can go ahead and hide that again. It's just that now, in all of the logic here, we're going to have to shift the -1 over to the other side. And over here, instead of +1 means that's our endpoint. We need to +2 now. And we need to flip the signs from minus to plus, because now we're now looking ahead of us, not behind us. Alright, now we don't have the errors anymore and all of our code still works just like before. Now obviously the one thing I changed about this code is that the item spacing shouldn't be here. In fact, it should be related to the item itself. That way the item is responsible for making sure it doesn't collide with everything else. But that also means that you'll have to change the collision detection logic accordingly. Now there's one last thing I'd like to change before I end off this video. You'll notice that we're running the entire for loop in update. If you recall, update runs once every frame. This means that if we have 10 items in the conveyor belt list, and we're running at 60 frames per second, this means 60 times 10, we're running this for loop 600 times every second. That's not very optimal, especially if you plan to have multiple conveyor belts and lots of items on it. The simplest change that we can make right now is to turn this from update into fixed update. Fixed update runs at a slightly slower rate, and this is usually used for physics. However, I do recommend looking into slowing down the execution of this method even further. In a game that I use this logic for, I used a tick system. The tick system essentially runs not every frame, but at a designated interval. There are loads of tutorials online that will teach you on how to make a tick system in Unity. The tutorial I referenced the most was CodeMonkey's tick system. It's a great tutorial on how to make a very versatile tick system that can be used in almost any game. In fact, I think he uses his own tick system for his own conveyor belts. And that's it. This is the conveyor belt system in action. In fact, I used this for a game that I submitted to the school. I'm pretty proud of this system and hopefully it goes well for you too. If you have any questions, do let me know in the comment section below. Thanks for watching and I'll see you in the next video.